One, two, go. Alright guys, welcome to our channel. Thank you for being very consistent, for subscribing, commenting. We are so grateful. Today we'll be looking at heat and we'll be solving question number 2. That is the second question on this topic, heat. How much heat energy is needed to convert 0.04 kilogram mass of ice at negative 4 degrees Celsius to steam at 100 degrees Celsius? The specific latent heat of fusion of ice is 288.0 kilojoules per kilograms. Specific latent heat of vaporization of water is 3340.0 kilojoules per kilograms. Specific heat capacity of water is 2.02 kilojoules per kilogram per Kelvin, and specific heat capacity of ice is 3.2 kilojoules per kilogram per Kelvin. Okay, we have a solution and we have the data. The question we're asking for the total amount of heat that is needed to convert this mass of ice at negative 4 degrees Celsius to 100 degrees Celsius. That's the question. And the mass of the ice is 0.004 kilograms. The temperature of the ice, called that θ1, is negative 4 degrees Celsius. The temperature at which they want us to convert the ice temperature is 0 or 100 degrees Celsius. The latent heat of fusion of ice is 288.0, and of course we have the other values here which we just mentioned. Now we have for arrow diagram here telling us we are converting firstly ice at negative 4 degrees Celsius to ice at 0 degrees Celsius. We need a heat energy there. We call it Q1. Then from 0 degrees Celsius, ice at 0 degrees Celsius to water at 0 degrees Celsius, we need heat energy also, called that Q2. And then from water at 0 degrees Celsius to water at 100 degrees Celsius is Q3. Then water at 100 degrees Celsius to steam at 100 degrees Celsius is Q4. Let's look at Q1 first. Q1 equals the mass of the ice times the specific heat capacity of the ice multiplied by the difference in temperature from here to this temperature. So we plug in the values for the variables. We have 0.004, that is the mass of the ice, times the specific heat capacity of the ice is 3.2 kilojoules per kilogram per Kelvin. We have to convert this to joules, right? So we multiply by 1,000. If we multiply 3.2 by 1,000, we get 3,200. Then we multiply everything here. Our answer for Q1 is 51.2 joules. Then we quickly look at Q2. Q2, now we are converting ice at 0 degrees to water at 0 degrees, so the temperature is the same. So the latent heat involved is latent heat of fusion. So the mass of the water, how do we get the mass of the water? At this point, when ice melts, right, the ice is 0.004 kilogram. So when we melt this ice, it will have the same mass. So the water now will be the same mass as the ice. So I'm going to emphasize and say, at this point, the mass of the ice is equal to the mass of the water. Please remember that. The mass of the ice at the point will be equal to the mass of the water. Okay, We say 0.004 kilogram times the latent heat of fusion, specific latent heat of fusion of the ice, is 288.0 kilojoules. So we have to convert this to joules per kilogram. Convert that, we have 288,000. Multiply that by 0.04, we get 1,152 joules. Then we look at Q3. Q3 we are converting from water at 0 degree to water at 100 degrees Celsius. So we see that there's a difference in temperature. It will be equal to the mass of the water times the specific heat capacity of the water. Specific heat capacity is 2.02. Convert that again, we get 2020. The difference in temperature, 100 degrees Celsius minus 0 degrees Celsius, we get 100. We will multiply all these values here. We get 808 joules for Q3. Now we look at Q4. From this point, water at 100 degrees Celsius to steam at 100 degrees Celsius. So the latent heat involved here is the latent heat of vaporization. Remember, temperature is the same here. Okay, so temperature is not altered. Now Q4 equal the mass of the water times the specific latent heat of vaporization. Mass of the water is the same, 0.04, times the latent heat of vaporization is 3,340. It's in kilojoules, so we have to convert that. So if we convert that, we have 3,340,000. If we multiply that by 0.04, our answer is 13,360 joules. Now the question says the amount of heat that is needed to take this ice from -4 degrees Celsius to 100 degrees Celsius. So we're going to add all of these values, Q1, Q2, and up to Q4. Therefore, the total heat will be equal to the first heat plus the second heat, the third heat, and the fourth heat values that we got. We add all of them, the final answer is 15,371.2 joules heat quantity needed to convert 0.04 kg mass of ice at -4 degrees Celsius to 100 degrees Celsius. Thank you so much for watching. Don't forget, watch this video, share the video so that someone else will be educated, someone else will receive the knowledge. Thank you so much.